My name is Skyler Lambert, and today I'm going to talk about quantum computers. Quantum computers are built to take advantage of quantum mechanics, which is an entirely new way to study our world. Basically, quantum theory states that the classical laws of physics no longer apply when we examine subatomic particles. And by classic laws of physics, I mean things we take for granted, like your cat being either alive or dead, but not both at the same time. In the quantum realm, it can be both. What? How can that be? Well, electrons behave entirely differently than objects we're used to. Thomas Young's double-slit experiment demonstrated the wave-particle duality of electrons and proved that we can really only know one thing about any particle at a given time. This is called the uncertainty principle. For example, if we measure an electron's spin, we can't know its position, and vice versa. That is a very simplified explanation of the principle of superposition. Electrons exist in multiple states at once, but we can't observe this behavior because by looking at a particle, we force it to choose a state. But if you're really sneaky, you can observe a particle without looking at it. By applying an outside force to two particles, you can entangle them, and they will sync their properties. Looking at one of the paired particles will give you information about the other. But what does all this have to do with computers? Computers operate using transistors, which are like little gates that either allow or block the passage of electrons, which translate to bits, the most basic unit of data in a computer. Bits can either have a value of 0 or 1, but not both. Transistors keep shrinking so more and more can fit onto a chip, increasing our computing power and meeting our ever-growing demands. But if we make transistors any smaller, electrons will be able to pass through a closed gate anyway, which is called quantum tunneling. This is where quantum computing can be useful. Traditional bits can be replaced with quantum bits, or qubits, which are bits in a state of superposition. They are both 0 and 1 in your system. And if you have a system with multiple entangled qubits, the power increases exponentially. But this increase doesn't make your computer do things exponentially faster. It allows your computer to run exponentially more functions at the same time because the qubits have an equal probability of being 0 or 1. Quantum computers are ideal for password guessing because they check all the options at the same time, whereas a regular computer would do one at a time. Science discovered the principles of quantum computing years ago, but we are only beginning to unlock the mystery and potential of this new realm.